And liftoff of the Atlas V with Curiosity, seeking clues to the planetary puzzle about life on Mars.
At 10:02 a.m. on November 26, 2011, the launch of the highly developed and technologically advanced rover signified another step in the search and exploration of the planet Mars.
NASA had 4 missions.
Mission 1. Discover if Mars can support life. It is essential that the environmental conditions present become understood in order to determine if life can thrive on the barren planet.
One of the various instruments that help gain information regarding life on Mars is SAM. It takes and analyzes soil samples with its gas chromatograph, mass spectrometer, and tunable laser spectrometer in search for carbon, hydrogen, and oxygen in Mars's atmosphere.
The Mars Reconnaissance Orbiter determined the clay in Gale Crater was a product of the original water source. Unfortunately, the pebbles were too small to drill into for research. At a separate site in Gale Crater, the clay was viable for research and concluded to be a part of a once aqueous environment.
Mission 2. Characterize the climate. Past and current climate must be studied in order to find information regarding weather patterns, atmospheres, and the distribution of water, CO2, and hydrogen.
REMS is Curiosity's built-in weather station. According to NASA, it measures and provides daily and seasonal reports on atmospheric pressure, humidity, and ultraviolet radiation at the Martian surface, air temperature, and ground temperature around the rover.
Water once ran freely on Mars because of deuterium. Deuterium is an isotope of hydrogen that has a neutron in the nucleus, unlike protium, and is found in abundance in Earth's oceans. The Strathdon is another example of free-flowing water. It is made of dry sediment layers likely formed by wind or water erosion.
Mission 3. Characterize geology. Processes that created the Martian crust must be determined, or the evolution, composition, structure, and dynamic of Mars's interior shells become investigated. The rock and soil record also will give scientists a plethora of information about its creation.
ChemCam takes soil samples, vaporizes them, and measures them in order to gain information on the microstructures and minerals of rocks on Mars. It also includes a camera to provide detailed images of these materials.
On Mars, there are organic compounds up to 3 billion years old, some with chlorine. The organic carbon concentration is up to 10 parts per million. This gives ideas for how the molecules were formed and the geological processes that occurred.
Mission 4. Prepare for human exploration. Goals include going into Mars's orbit, landing on the surface, and at least one of Mars's moons. Implementing sustained human presence on the surface is also a goal. Any potential hazards present must be found so safety measures can be put into effect. All of this must be done with an acceptable cost, risk, and performance.
MEDLI is an instrument that took measurements of atmospheric pressure during Curiosity's descent onto Mars to find out what effects the changes in atmospheric pressure would have on different parts of the spacecraft. This will help researchers in their future spacecraft designs.
The methane and radiation levels on Mars are a substantial risk for humans. Methane levels rise and fall seasonally with no known sources. The radiation is similar to the International Space Station.
Questions surrounding the possibility of Mars harboring life, its climate, geological conditions, and the ability to implement human missions now have more answers than ever before thanks to the Curiosity rover.